welcome back. Now we're here in the Fluids Lab with Matt from the technical team for civil engineering and construction. So, hi Matt, can you tell us a little bit about the flume, what equipment like this is used for, and also who uses it?
Yeah, so this is our 10-metre flume at the university. The flumes at the university are used by the built environment and the natural environment. So the natural environment use this one in particular for its wave generator, looking at how sediment erosion in beaches affects coastal erosion, and the built environment use it predominantly for culverts. We use it for dam spillways like the one that we've got here in a second, and we use it for sluice gates. So what we do is we push some water through it, then put an obstacle in place. This machine here tells us how the fluid will react once we put an obstacle in place, and we can take some various measurements on that. Should we start it up and then I'll explain it as we do it?
Great, yeah, just to let you know viewers, this may get a little bit noisy.
So it just takes a few seconds to turn on. So water's going to come from that end. At the moment we're going to be pushing it through at about 12 litres per second. What that's going to do is come up and hit the dam. It will then take a little while to fill up. So what this one is replicating as such, this would be a body of water, something similar to a reservoir. What we then need to do with the reservoir is discharge it to something that's going to be useful. So say Severn Trent Water have one just outside of Derby, and they provide water to Derby itself and Nottingham. What they then do is discharge however much water they need to come out of it to meet the demands of Derby and Nottingham itself. Our students, what they will do is looking at the height of the water up here and the height of the water going over the dam itself. And what we can then do is work out how much water is going to come out of it. One of the big problems with dam is just at the end here, what we call this is subcritical flow, and going over the dam itself is supercritical flow. The supercritical flow is high energy. So once it goes over the dam itself, it causes a lot of bed erosion. So what we do here is put a little ski jump over it, and that helps us dissipate the energy to get it more to the subcritical flow and stop damaging the river slightly further down the dam itself.
So I guess this mirrors what students would experience when they go into the world of work.
Yeah, very much so. So once we design this sort of stuff, it's very important to do our theoretical calculations. But what this helps us do is model it in the real life as well. So once we work in industry, what we are doing is theoretical calculations, something called finite element analysis on computers, and then what we can do is test it in a model like what this is, just scaled down.
Fantastic. That's so great to see. Thanks, Matt.